Hello everyone. Today we'll be talking about indexes in MSSQL. What are the different types? What is the syntax to create an index, and what are the advantages and disadvantages of it? Okay, so we have talked about it in the previous one or two videos where we see there is a performance issue, how we find the blocking queries, and all the stuff. So indexes does plays a very important role. So we'll try to understand all of that today. Okay. So to start with, here is the general syntax to create an index. So like how you create a table or anything as such, it follows a similar kind of syntax. So you give a create index and then you give the index name. So it is recommended to follow a similar naming conventions so that it is easy to read and understand. Okay. So for the index, we are giving it as an IX and then table and then the table name. So you're going to create this index on this table and then on this column. Okay, so here you can see this is my table and these are my columns. Okay, you can also create an index using an UI, not just the query. For that, you need to come to your table. You have this folder as indexes. It will show you if there are any existing ones. We'll also talk why there is already a index created as a primary key. Okay, but if you want to create using an UI, you can use this option. Right click and then go to new index. There are different types of indexes which we'll be covering. Okay. For example, if I want to go for the non-clustered index here, so this is a table name and here is the name you can give. Okay, I can change it to anything and then you can also use the unique constraint here and plus you can add the columns. So either you can add one or multiple columns while creating an index. If you are using more than one column, we usually call it as a complex index. We'll also talk about it and see how it works. Okay. As of now, we'll not be creating using an UI, but we'll go with the queries. For you to know the existing index, you know now one way that you can come to the UI and expand the table and then indexes and you will see the existing ones. But if you want to check using the any of the stored procedure or something, so you can use this. So sp underscore help index and give the table name. So if I run this one, I should be seeing a primary key index that is already there. Okay, so if you want to delete, if you want to remove any of the indexes, you can also do that using the drop index query. Again, the syntax follow the same. You always mention which table and which index when you are creating, when you are dropping. If you want to check all the indexes on the table, you just go for sp underscore help desk and then sorry help index and then you go for contents. That's a table name. Okay, so that's about the uh, generic way of creating an index. We are not talking about any particular type here. Okay, so let me just quickly run this one. So you see it is created. We'll run to see what are the indexes. So you can see there are two indexes on the same column. Okay, we'll also check by dropping the one we created now and we'll run to see again. There should be only one index. Okay, in case of you see any error while dropping an index, if it says there is a restriction or if it says already there is any uh, dependency or anything as such, you can always come to UI and right click on any of the index that you want to delete and you have option here. So this will be quick and it won't throw you any errors. Okay, if you come across any error, maybe we'll also see the demo of the same. Okay, cool. Or we'll simply do it right away. I'll create this one and if I expand this and then refresh, I have two indexes. I will delete this one. Okay, so we are left with only one. Okay, that's how we do it using UI, either for to create or to drop. Okay, we'll also talk about different types of indexes now. Okay, the first one is the clustered index. This is a very important index, mainly used in most of the tables, I would say, because we'll see the features of it and how it makes your life better. Okay, so what is clustered index? Clustered index will also define the physical order of data in your table. Okay, so it doesn't exist separate from the table, it's within the same table. So index and the main table, they exist together. Okay, so whenever uh, so let's say you have a key or a column that is used regularly as a reference to fetch the values. Okay, so if you take it as an employee table or something, so employee ID is a very unique key which you more often use for any transactions to fetch the record from that table, right? So if you put a clustered index on that column, it is very easy and helpful. We'll see how it is. Okay, when we talk about the difference and all the other stuff, we'll also see the how it is making a difference when you are running a query. It has both advantages and disadvantages when you create an index. That is why it is important that you be careful when you create, how you create, and how effectively it is being used. Okay, you can create an index on every table, even be it having a very small data or having a very large data in that table, but how impactful it is to our queries that we run. It should not create a blocking or a performance issues. Okay, so since it defines the order of the table, there is a restriction that we can have only one clustered index on a table. We cannot have more than one. Okay, so like we saw here, whenever you put a primary key constraint on any of the column, automatically it creates a clustered index. Okay, so for example, in this table, I have primary key for the contest ID. That is why you see there is already by default. You don't need to manually create a clustered index when you are putting the primary key constraint. It's automatically generated in the backend. Okay, so you can see the type of it. It's a clustered and unique constraint is also put along with it, and primary key constraint is also present. Okay, you can also create one if you want, but yes, by default, whenever there is a primary key constraint, it generates in the backend. The syntax goes the same. Create clustered index instead of just index. We mention the type of it, and then we give the column name on which table and column. Okay, sorry, the index name on table and the column. Okay, like I said, it can also be one column or it can have more than one columns when you are covering the indexes. Okay, so if you want to create a one index for multiple columns, we call it a complex index. So the syntax remains the same. Only thing, the columns you are going to list in these brackets for the table, it goes as per the need. So in this case, if I want to go for contest ID as well as hacker ID, I can create a complex. So first it order the data based on the contest ID. Within that, it will order the hacker ID in a descending order. Okay, I hope it is clear for the clustered index, and we'll also talk about the non-clustered, and then we see what's the difference between those two. Okay. So in the case of non-clustered index, the data is stored in one place, whereas index is stored in some other place. Okay, so you remember in the clustered, it's a one table altogether. Index as well as the main table stays at one place, whereas data and the indexes are in a different place in case of non-clustered index. So this gives you an advantage to have any number of non-clustered index. So no need to have only one, which is the case in clustered index. And when it is separately going to exist, it is not also going to affect the order of data that's going to be in your main table. You can have any kind of any sort of order of a data in your main table, and still index also exist independently. Okay, the syntax going to remain same. Create a non-clustered index on which table and the columns. You can also put more than one column here again, like to make it a complex index. The concept and the syntax gonna remain same throughout. Okay. Okay, and we'll also talk about the the unique index. Unique constant, unique index, there is not much of a difference. So it's only gonna ensure there is a unique values in a given column. It's not gonna have multiple or duplicate values. Okay, that's the whole purpose of it. So like you see, when you create a primary key constraint, it automatically add the clustered index plus also the unique constraint to it. Right? Similar way, if there is none, you can still go and create a unique index. Okay, what are the features of it? It can be both clustered and non-clustered. Okay, so you have that um, free hand to mention whether the unique index you're going to create to be a clustered or non-clustered. Okay, so if it is going to be clustered, it has to be only one. If it is non-clustered, we can have multiple unique index. So primary key constraint automatically creates a unique clustered index. Okay, so you can see here we already have an example. Okay, it's not going to create us a non-clustered. Okay, since primary key can be only one for the table, we cannot have more than one. So clustered is also only one, and unique is of course primary key cannot be duplicates, and the unique constraint also ensures the same. They cannot be duplicate values in the same column. Right. So all together they come together and create unique primary key constraint and a clustered index automatically when you put a primary key constraint on any of the column. And the third feature is unique constraint also add the non-clustered unique index by default. So when you create an unique constraint, right? So many times we put a unique constraint on a column, be it not primary key alone. Okay, let's say in this example, I want to put a unique key constraint on hacker ID to ensure there are no duplicates. Since it is a contest table, it is expected that we'll have more than duplicate values in the hacker ID. Okay, so for example, you take employee table. Employee ID is already a primary key with a unique constraint and a clustered index. Let's say I also have an email address, a column. Okay, so which is also expected to be unique. We cannot have duplicate values in that case. So if I am mentioning a unique constraint on email ID column, so there will be automatically a non-clustered unique index which is created. Okay, talking about the syntax, it again remains the same. Create unique in non-clustered index, and you give the index name on which table and column. Okay, you can also make it complex or you can keep it a simple one. Okay, talking about the difference, what's the difference between clustered and non-clustered? Most of the time, most of it we already covered. One is only one clustered index can exist on a table, whereas for non-clustered you can have more than one. And non-clustered index are of course slower when you compare to the clustered one, because the index and the main table, they exist independently. So when you run a query, it first goes and look for the index table, and then from there as a reference it comes back to the main table. So there is a lookup to index first and then to the main table. So this will take a time to get the result set for you. So you can see when you fetch a larger data or when you fetch a complex data, it will take more time. Okay, that's why it's slower. Clustered index decides the order of data, so there is no lookup, right? So it's a main table. For example, it's a contest ID. In this case, I run a query to fetch a result set saying as a reference to the contest ID. So it comes to the table. There is already a data that is in certain order, be it descending or ascending. and then it fetch from the same table and give me the result set. The index also is on the same column, as well as the main table is also exist on the same place. So there is no lookup in this case, so the clustered indexes are faster. Clustered index does not require extra disk space. Yes, so because they exist on the same table, whereas non-clustered, again it requires extra space for the index to be stored. Okay, and while we are talking this one, you can also identify there is an uh, little of a disadvantage when it comes to non-clustered or be it clustered index. The whole index concept can also be a disadvantage for creating any of the modification queries, be it update, delete, or insert, right? Because when it comes to non-clustered, if you are updating or deleting or inserting any of the data, there has to be an index also created and stored separately in an index table. Okay, so it's gonna consume more or reduce the disk space based on the operation you are performing, but it's gonna be extra upon the main table. In case of cluster, it's not the case, but again, the indexes also needs to be updated accordingly. It cannot have the duplicates or it cannot be left without modifying the indexes also. Alright. So that is why when you have a indexes on table, one thing is yes, your fetch operations might be faster. It is helpful if you have created the indexes effectively, but performing modification, deleting, updating, or inserting will have a impact, be it on performance, and it will cost you as per the timing to run a query. Okay, so that is why it is very important that you make sure you are creating an index effectively and it is not created just because it should be, right? Even in case of when a table have very small data, let's say my table in this case have only 3 rows, I don't need to have an index for this one. Either way, my query is going to take same amount of time, be it if I create an index. Maybe by creating an index, non-clustered index, I would increase the execution time. So if you have big data, let's say there are thousands of records in a table, then the index would definitely make sense. Again, where you put and what column you are going to choose, it's going to be very important. Okay, I hope you understood the different types: clustered, non-clustered, unique index, and what is the advantage, where you are going to use, and make sure you try and test on your table. Okay, of course you can delete at any point of time, and then you can see the difference in execution time, how it's helping you and how it's not. Okay, I hope this session helps you guys. Thank you so much. Bye bye.